So far, we've only found limits for numbers. We can also find limits as x approaches positive or negative infinity. So what that would look like is something like this. So limit of f of x as x approaches infinity. It just means what does y approach as x becomes infinitely positive. Similarly, limit of f of x as x approaches negative infinity means the same thing, except what does y approach as x becomes infinitely negative. These do not have left or right-hand limits because they can only be approached from one direction. If we wanted to approach positive infinity from the right, we would have to somehow get to the right of positive infinity. But the thing is, infinity goes on forever, all the way to the right forever. So it's impossible to get beyond it to somehow approach it from the right. There's only going to be one approach. So these do not have left or right limits because they can only be approached one way. Limits as x approaches positive infinity or negative infinity are really asking about what happens as the curve goes off the edge of the graph to the right or to the left. So, for example, here is our graph of f of x. As x approaches infinity, that means that x gets infinitely large. It goes off this way forever and ever and ever. And we're saying as x gets larger, what's happening with y? Well, we can see here it's a parabola. It's just getting larger and larger and larger and larger itself. So if x gets infinitely large, f of x, or y, is going to be getting infinitely large as well. So that means that its limit is infinity. It just keeps going on and on and on forever. And in this particular case, as x approaches negative infinity, the same thing's happening. This way, y gets larger and larger and larger forever. The limit's positive infinity. It doesn't have to always get larger forever, though. It could get more and more and more negative forever. So if we say, let's say this is g of x, let's say it looks something like this. In this case, as x gets more and more and more positive, g of x, y, is going down forever. It's getting more and more and more and more negative. It's getting infinitely negative, in fact. So the limit's just negative infinity. And over here, as x gets more and more and more negative, y is more and more positive, infinitely positive. So that limit is still positive infinity. Those aren't our only two options, though. There's one more. Let's say we had a situation like this. And let's say there's this line here. Let's make it at -2 or whatever. And what happens is that this curve comes up, it kind of wants to touch that line, but it never really does. It just sort of keeps going on that way forever. And maybe the same thing happens over on this side, going off in that direction. And what happens there is that we have what's called a horizontal asymptote. And this is what y approaches as x gets infinitely large. Now, when we're over here, the curve is more than welcome to cross it and go up and down and up and down. It's just that as x gets bigger and bigger and bigger, or as x gets more and more and more negative, it should start to approach, but probably not touch, this horizontal asymptote. So in that case, if we're asked for the limit as x approaches infinity of h of x, it's not positive or negative infinity because it's approaching this number, this negative 2. So that's just our limit. Likewise, in this case, the limit as x approaches negative infinity, that was also approaching this horizontal asymptote, negative 2. It doesn't have to be the same one, but in this case, it happens to be. So like we just said, if there's a horizontal asymptote, it doesn't mean that both of them have to approach it. So for example, if we had a function like this, which is just an exponential function, let's say we've got a horizontal asymptote here at 3 or something like that. Let's say that it comes along like this. Here's the function. And it's coming along to get really, really close. Let's see, that's not very well drawn. That's better. As x approaches positive infinity, j of x gets closer and closer and closer to this horizontal asymptote at y equals 3. But as x approaches negative infinity, y is getting larger and larger and larger, more and more and more positive. The limit is positive infinity. Finally, we can have a function that looks like this. Let's say this here's crossing at 1, this here's crossing at negative 1. It's just a constant line. It's just that there are two different constant lines. And so it just is negative 1 forever. It gets toward infinity. Limit's still negative 1. Going this way, positive 1, positive 1, positive 1, stays being positive 1 all the way up through infinity. So to summarize, when x approaches infinity or x approaches negative infinity, there are 3 options. The limit can be positive infinity, negative infinity, or it can have a horizontal asymptote at a particular number.